Okay, now let's talk about
Now let's learn about linked lists, which have a lot of overlap with arrays, but also a lot of differences. The first thing to know about linked lists is that they are made up set to null, so it's not pointing and then back to the blue node, back to the green node, and just kept doing that over. The time complexity of this operation. If we say dot next one more time, we're following this pointer instant time because we don't have to. Next, let's look for, and that makes return the index mid. Yes, it is.
Okay, so now the code like this node with that value. So we're going to code with items in it. Let's start with the empty one. In this situation, we're just going to have head and tail point to the new node. So in order to do this, we have to test to see, is the list empty that we're inserting? So now let's take this code and put it in with the rest of our code. So the other scenario we can have is that we actually have items in the list. So we'll say else, and let's build out this else statement. So we want this code, and we'll say head equals new node. We'll move that over, and that adds that into the list. So now let's look at, we're going to return true, and this is an optional line of code here. And as I mentioned with append, I'm going to be using append in a few videos. This is going to create that initial linked list with the 2 and the 3 in it. And then here we're going to print that out, that list with the 2 and the 3. Okay, and there is our 2 and our 3. And then what I'm going to do is I'm going to come down here and I'm going to paste in our line there. And now when we do our print list, this should print out 1, 2, 3. So I'm going to run this. And that prints out 1, 2, 3.
So I think we've learned enough to 0. Unfortunate path. So from here to a 0, we would have gotten here. We would have went to the left path. We would have found that no, this was not the answer. We returned false up to our parent here. So we would, backtrack basically back up, try it from the right subtree. We would see that this is a 0. So this was not the path either. We ran out of options. We backtrack up. And then from here, we return false to our parent. And then from here, we would also return false. The answer to this question then would have been false, not true. So the code for this solution would look something like this. You can see it's pretty similar to the other tree traversals, the recursive ones that we already looked at. So in this case, the Welcome to the Object-Oriented Design Patterns course. In this course, we will be going over 8 of the most commonly used design patterns, including some creational patterns, structural patterns, as well as behavioral patterns. In each lesson, we will be going over the motivation behind every single pattern. Why exactly do we need these? What problems do they solve? There will be UML diagrams for every single pattern, as well as code in Python, JavaScript, Java, and C++. There will be video lessons as well as an article below every single video. The articles are a bit more in depth. They include more details, so you can either read through them or just use them as a reference, though they have a lot of overlap with the videos themselves. The videos are a bit more concise than the articles. And when it comes to practicing these design patterns yourself, which in my opinion is the most important thing, you want to get hands-on as much as you can. And to make that easier for you, I implemented some code sandboxes for every single pattern that we will be going over in the course. So for example, this is the one for the adapter pattern. It's supposed to be like a leak code style problem where you kind of have a problem prompt. They are relatively short. I tried to keep them short. And then you'll have some boilerplate code and you need to finish the implementation of that code. So you can see here is an adapter and you just need to finish the implementation of the adapter class here. Now, in terms of the problem, there is a solution and is not the best object-oriented programming language. So without further ado, let's get into the course. Let's talk about the factory method pattern. It's a creational pattern, so it's all about abstracting away details of objects that we are creating. And there are some other benefits as well that we'll go over, but for now, let's start with the motivation. Why do we need a pattern like this anyway? Well, an analogy would be when you go to a restaurant. When you order some type of dish or meal, you don't necessarily have to specify like all of the ingredients that go into that dish. So that's kind of one level of abstraction. As like a customer or like a user, you usually go through a waiter and then tell them your order, and then they tell the chef, and of course the chef is the one that actually builds or creates the dish. Now, one more level on top of that at a restaurant, or especially with drive-thrus, is sometimes you might order a combo. And that can have specific like items, multiple items, maybe item 1, item 2, etc., etc. The point is that it's generally better to go through a simple interface rather than specifying all of the details. Now, in terms of code, that looks like instantiating an object, usually with the new keyword, depending on the language that you're using. And when you instantiate some object, I'm just going to call it object for short, typically we have some parameters that go into it. Parameter 1, parameter 2, and sometimes it's not as simple as just providing simple parameters. Like we might have a very simple way to instantiate this object. We might pass in some like Boolean, we might pass in some integer like 10, but it can get even more complicated. What if this object actually requires other objects for us to instantiate those so that we can provide those objects to this object? Things can get kind of messy, so that's one benefit of the factory method or factories. in general. Now, if we were not to use a factory and we were kind of instantiating complex objects like this all around our code, things might get messy. And also, depending on the case, like sticking with our restaurant analogy for now, we might go with like dish one, or if it's like a fast food joint, we might go with like a specific type of burger, and you might have like a deluxe burger, and we might, in some cases, have code that ends up looking something like this. We might have like a switch statement or a bunch of if statements, which, depending on the type of burger that we're implementing, we will instantiate that specific burger. Now, in this case, we don't actually like pass in the ingredients and all that, but this is another sort of issue. Like, let's say that all of this code is actually wrapped in some type of method, and the method accepts the type that we are instantiating, the type of burger. And for the record, this code is not wrapped in a factory method or any type of class. This code, depending on where we need to use it, could show up in multiple classes. And obviously that's a problem because we're kind of duplicating code, but it might not look exactly like this. For some cases, we might not have some of these. But the point is that we don't need to duplicate all of this code. So one very simple improvement we can do is maybe put this code inside of something that we call a factory. But in reality, that's not the factory method. If we were to wrap this in a class, that's actually known as a simple factory. Some people don't consider that a true design pattern because it's very, very simple. It's very trivial. It's basically a wrapper. Now, that's not bad, and in some cases, that might be the solution that you actually go with. But there actually are a couple issues with this approach as well. Because now the improvement is that if we have a bunch of classes that need to instantiate a burger, they can all use this same piece of code. They can share that piece of code, and that's the benefit. But the problem here is that if we were to now introduce new burger types, we would have to then modify this class. And that's not a huge deal, but it does technically violate the open-closed principle. It can lead to potential bugs. Like anytime you're modifying some piece of code, you might introduce new bugs. And if, like we showed, like there are multiple classes depending on this piece of code, that can definitely cause bugs. So that's issue one. It technically violates the open-closed principle. But not only that, when we actually have some dependency, like some piece of code, some class is relying on this, we still, for that class, it still has to pass in the type of burger that it wants. In other words, that piece of code has to know details about the dependency. But if we want to kind of follow the dependency inversion principle, then what we would actually want to do is provide that dependency to the class rather than that class having to know about the dependency itself. It shouldn't have to know what type that this method accepts anyway. So there is a approach to solve that problem, to invert the dependency. The downside is it's going to take a bit of work to arrive at that solution, but it's not super complicated. It just requires a method accepts anyway. So there is a dependency, like some piece of code, some class is relying on this. We still, for that class, it still has to pass in the type of burger that it wants. In other words, that piece new burger types, we would have to then modify this class. And that's not a huge deal, but it does technically violate the open-closed principle. It can lead to potential bugs. Like anytime you're modifying some piece of code, you might introduce new bugs. And if, like we showed, like there are multiple classes depending on this piece of code, that can definitely cause bugs. So that's issue one. It technically violates the open-closed principle. But not only that, when we actually have some dependency, like some piece of code, some class is relying on this, we still, for that class, it still has to pass in the type of burger that it wants. In other words, that piece of code has to know details about the dependency. But if we want to kind of follow the dependency inversion principle, then what we would actually want to do is provide that dependency to the class rather than that class having to know about the dependency. Itself. It shouldn't have to know what type that this method accepts anyway. So there is a approach to solve that problem, to invert the dependency. The downside is it's going to take a bit of work to arrive at that solution, but it's not super complicated. It just requires a few more classes. So here is the generic diagram for the factory method pattern. This, of course, does not include like our concrete burger analogy. We're going to take a quick look at this before moving on to the next diagram. The idea here is that we have certain products. Now, in our previous case, that would be the burger, and we could have specific instances of the burger. We call those the concrete product in this case. So that might be like vegan burger or like a cheeseburger or a deluxe or whatever, right? The detail isn't important. It's just that there are different types of burgers, but they all either inherit from a superclass, a base class, or they implement some interface. And the benefit of that is going to be polymorphism. These instances can be substituted for each other. So that's one. And here's the part that actually makes this the factory method. This is what actually allows us to follow the dependency inversion principle. We have either an interface or an abstract class. The important part here is that there's going to be some factory method, such as get burger or maybe cook burger or whatever, right? So something like that. And in most cases, it's not going to have an implementation because we're actually going to have subclasses called concrete creators. And these are going to be sort of analogous to the concrete products. Like this could be something like vegan burger creator, and I'll just write a vegan creator for short. And we could have something like cheese creator. So as you can guess, these subclasses are going to have one responsibility, and that is to create that specific burger, that specific type of burger. Now, this solves the two big problems we were talking about earlier. The one problem was anytime we add a new burger type, now we don't have to modify that one class that encapsulated everything, that single class that created all types of burgers, because now we have individual classes for each burger type. So if we introduce a new burger, we just have to create a new subclass for this, and that will create that new instance of burger. So we're not modifying existing code, we're adding new code to add new functionality. And second, if we have some class, I don't even know what to call it, let's just call it restaurant, just to fit into this analogy, I guess, but we have a restaurant, and maybe depending on the day of week that it happens to be, there are different burgers that are available to us. So previously, the restaurant or whatever class is using the burgers would need to know which burger am I cooking. I'm cooking like a cheeseburger this time, or I'm cooking a deluxe burger or a vegan burger or whatever. It would need to actually send that information to the class that it's using. But now we've inverted the dependency. Now, if we want this class to use cheeseburgers, we are going to pass cheeseburger creator as a dependency to this class. If we wanted to create vegan burgers, we would pass those as a dependency into this class. So this sort of decouples the restaurant from the creators. So now let's take a look at the diagram. But it's going to be pretty similar to what we kind of just talked about right now. So like I mentioned, we have the abstract class or interface. In this case, it's a burger. All of these are going to inherit from that or implement this interface. So they are also going to have the burger type. And similarly with our burger store here, it's abstract. So we will have concrete burger stores that actually create specific types of burgers. And again, these will have the burger store type, and since they have that type, that's what will allow us to invert the dependency. We might have some classes that will, instead of depending on the concrete burger stores, they will actually depend on just the generic burger store. So we will be able to pass these in as dependencies to those classes. Notice that the create burger method is what's going to be overridden by these subclasses. And notice that this create burger method, it's not returning a cheeseburger type, even though it technically could, because this is only going to create cheeseburgers. Same with the vegan burger store. It's not returning a vegan burger type. And that's because when we substitute these in for the burger store, we want them to return the generic burger type, because that just allows more flexibility, again, with the dependency inversion principle. Now, of course, the downside to this approach, as you can kind of see, is there is increased complexity. Depending on how you look at it, maybe a simple factory might have been sufficient. We talked about some of the potential downsides, but depending on how simple our use case is, it might not be worth it to introduce all of these classes, especially if we know we're not going to need new types of burgers in the future. So I will go ahead and leave things there, but if you want to see a detailed implementation of like how we would code something like this up, I recommend clicking the code yourself button below the video, where you can actually try to implement this yourself. And that's really the best way to learn. And you can also watch a solution video of me implementing the same code. Let's talk about the factory method pattern. It's a creational pattern, so it's all about abstracting a Now let's talk about the singleton pattern. It's a relatively simple one. The first time I learned about it though, I was pretty surprised that it was even possible to do something like this. We'll talk a bit about the motivation behind this pattern, how it's implemented, some possible use cases, as well as why in many cases it's actually considered an anti-pattern, though you will see it probably implemented in the wild in some cases, or almost definitely you will see it. You might not see it in its most rigid form, but even state management libraries like Redux kind of use the singleton pattern. So I'm actually going to start with what the singleton actually is. As the name kind of implies, single means that there's just going to be at most one instance of this class instantiated at any given time. So let's say we have some class, let's just call it A for short, class A, and the singleton will basically guarantee that at most a single instance of this class will exist at any point in time. Now, why would we want something like this in the first place? Well, the simplest example is if we want something for shared state, like we want to share some state across our application, our code. And for us to do that, we want just a... Let's talk about the factory method pattern. It's a creational pattern, so it's all about abstracting away details of objects that we are creating. And there are some other benefits as well that will go single instance of that state to exist, because if we had multiple instances of that state, then those copies might go out of sync. We might update one but not update the other. One might become stale. So by having just a single copy, we will ensure that the state is always up to date. All consumers of this instance are going to see the same state. And there might be cases where we just don't need more than one instance of a class. Like, for example, if we have something like a logger, we may not need more than one instance of that. It may just take up additional memory when it's not actually necessary for us to do that. But in terms of the implementation of a singleton, it's actually pretty simple once you know it, but it is kind of clever if you're new to object-oriented programming. Let's take a look at this class. So this is for a printer service, though to be honest, the example itself isn't super important, but assume in this case we have a printer service and we want all consumers of this printer service to be able to see the same state. So you can see we have a string variable here. By the way, this is Java code just because it's a bit verbose, and I think that actually helps when it comes to understanding exactly what's going on here. So we have a string which refers to the mode, and this is kind of our state in this case. This is what we want all consumers of this class to see. And the first thing about the singleton pattern is that it has a constructor, just like pretty much every class has a constructor, but notice that this constructor is private. So that means we do not instantiate this class with the new keyword. We don't say new printer service, because if we had that, if we allowed that, that would be a problem, because then we could probably instantiate multiple instances of this class, but we don't want that. We want it to be a singleton. So we make the constructor private, but we do something pretty clever here. We have a function called getInstance. And this is public, so this is how we're actually going to be fetching an instance of this class. But it's also static, so you don't instantiate an instance of this class to call this method, because we can't instantiate this class, at least from the outside. So if we wanted to get an instance, we'd say printer service dot get instance. I won't write it out, but you get the idea, right? We're going to call it from the class itself. So that's what we're going to do. And then inside this class, we do something clever. For now, let's actually ignore this part of the code. So assume that this is the code. I know it's kind of messy, so I apologize for that. I cleaned it up a little bit to make it a bit more readable, just to kind of ignore the indentation. We have this method, and notice what it does. It checks, is that unique instance? We have a variable up here. Its type is, notice, printer service. That's kind of recursive in a way. Like, we have an instance variable of the class itself, but there's no problem in doing that. There's no issue for us to do that. It's technically legal. And initially we set it to null. That means there's no instances instantiated of this class. The first time we call getInstance, we're going to notice that yes, it's equal to null. So what we do is we instantiate an instance of the class. We're allowed to do that from within the class, because that's just how OOP works. Just because this is private doesn't mean we can't call it within the class. So we create an instance and then we return it. And then the next time we call getInstance, this is not going to evaluate to true. We already have an instance. So instead of creating another one, we're just going to return the one that we already have stored. So that's kind of the clever part of the singleton. That's how we can guarantee that at most a single instance will be instantiated at any given point. And then here we just have a couple methods basically to get the state as well as set the state. And by state, I just mean the string called mode in this case. You might be wondering, what was the rest of that code for? Well, I won't get into the details too much. The short answer is that we use these, and by the way, since this is Java, this is obviously Java specific, but I think the idea will hold regardless of the language that you're using. The main reason for this is to make this class thread safe. What that basically means is if we had our program which was multi-threaded and we were using this singleton class, we wouldn't want any issues arising. One potential issue if we did not have this synchronized block here is that we might have two threads at the exact same time calling getInstance, and they would both see initially that unique instance is equal to null, and then they would instantiate instances, and that might be a problem. And there are other problems that can result when you don't have thread safe code, even if your program is multi-threaded. So that's kind of what this is for. That's also what the volatile keyword here is for as well. And I will mention though that if we wanted to make this class 100% thread safe, we'd probably also have to update specifically this set mode function here as well. But that's not kind of what I want to get into. We're not here to get into the details of multi-threading, but I do think it was worth kind of mentioning. But I think the core part here to understand about the singleton is that we have a private constructor, we have a member variable for the unique instance, and we have a getInstance method that is static. It belongs to the class, and that's going to be instantiating at most one instance of the class. Notice though that for the singleton, it kind of has multiple purposes. This class has multiple purposes. It kind of does not adhere to the single responsibility principle because we have the functionality of the printer service itself, but we also have code here ensuring that it's a singleton. The diagram in this case is going to be pretty simple because the singleton doesn't have a lot going on. It's just a single class. And yes, it's going to have a unique instance variable that's going to be private. The constructor is going to be private, but we're going to have a static get instance method, which is going to return an instance of the class itself. And any consumers of the class are going to be calling it from singleton.getInstance, not from the constructor. So not too much to discuss for the diagram itself. Now, there's a couple of reasons why people consider the singleton to be an anti-pattern. One is the rigidity of it. It's a bit rigid. We can only have at most one instance of a class. But what if we were to change our mind in the future? What if we wanted to allow multiple instances? Why can't we just make it so that the class initially starts with one instance, but maybe in the future allows us to have multiple instances? So that's one sort of drawback, but I will say that in my opinion, that's not the most significant one. The most significant one is that generally when it comes to programming, we are told to avoid global variables that can be accessed anywhere within the program. That's why we kind of scope things out. But having a variable or a class or an instance that is global, it can be accessed by anybody. And if it's, for example, used to manage state, well, it makes it hard to kind of track down how that state is changing. It might change unpredictably. It might be changing from many, many parts of code. So we might, sometimes have multiple pieces of code updating the state at the same time. It can get hard to track like the timeline of the state changes, which happened first, which happened after. Maybe we intended them to happen in a different order. So by doing that, it can make things very complicated. We could have 100 different places reading the state. We could have 100 different places writing to this state, and that gets complicated. So I think that's mainly what I wanted to cover. In terms of use cases, you can read the article below for some examples, but we already kind of talked about how logging services make sense to use singletons. We don't need multiple instances of a logger throughout our program. Operating systems can make use of singletons in many cases for things like config managers and other cases as well. Another benefit of singletons is the fact that they can be lazy loaded, meaning that you only instantiate an instance of the singleton when you actually need it. If we never end up needing it, we're going to end up saving memory. Depending on the type of program that we're trying to make, saving that memory can be very, very helpful. So I'll go ahead and leave things there, but if you want to implement the singleton or see a full code walkthrough of implementing it, you can click the Code Yourself button where you can try to implement it yourself, and you can also watch the video there. Let's talk about the builder pattern. It's another creational pattern, and it definitely has a lot of overlap with the factory method pattern, at least in terms of the motivation and a little bit of like the solution, what the builder does. But there are differences, and those will become pretty clear by the end of this video. A pretty basic analogy is we are creating some like meals at a restaurant, and we know that a meal can have many components. It can have like the drink, the main course, maybe like a dessert, and there could be other components. And similar to what we talked about with the factory, if we try to instantiate a meal, it can get messy, especially if we had even more components to this meal. Like if we tried to construct it with the new keyword, and suppose each of these is a parameter that we have to pass in, that is going to get kind of messy and also kind of confusing. And what if some of these were actually optional parameters, like we don't necessarily need a dessert for every meal? Well, that's going to make this even worse. It's going to make it more confusing. Now, when we talked about the factory method, it was a kind of a high-level solution to this. We had like different types of meals. Well, in that case, we actually had burgers, but we had different types, like we had distinct types. We could sort of do something similar with meals. We could create like a subclass for different types of meals. But in this case, like for this particular problem, you can see that that's actually not what we're looking for. There could be a large set of drinks, a large set of mains, a large set of desserts. And if we're going to subclass them for every different type of meal, well, that's definitely not going to work. I mean, it technically could, but it's basically like combinatorics. Like for every single possibility, like suppose there's 5 drinks, there's 5 main courses, there's 5 desserts, we're going to have 5 to the power of 3. I think that's like over 100 already. So we definitely don't want to get in that sort of mess where we're having to define so many classes. But at the same time, we do want to have some level of granular control over what the parameters are. And maybe some of them will actually even be optional. We won't even have to specify them. And one thing that's kind of a bonus of the builder pattern, actually, you can kind of tell, like with this meal here, if we were to introduce new components to the meal, then we'd have a new parameter for the constructor, and then we'd have to update all references to this constructor. But with the builder pattern, we can actually add to this meal without necessarily having to modify some existing code. So the main idea with the builder pattern, it's pretty simple, to be honest. In order for us to go from some starting point where we don't have anything and then to finally get to the final meal, we're actually going to build it step by step. So in one step, we might add the drink. In another step, we might add the meal, and then we'll add the dessert. So that's kind of the high level idea. It's pretty simple, like I said. And all of these steps don't necessarily need to be included. We might not include this step or whatever. And you can see doing it this way, we do have some level of control. We can still specify every single drink, every single possible meal or dessert. And when you see the code, you'll see that it is a bit easier to use than having like a really, really fat constructor. So here's like the high level UML diagram. I mean, it looks more complicated than it actually is. It'll make a bit more sense when we get into the code, but at a high level, we have certain products. And in this case, we are mainly talking about meals, like in our example. And we have, in this case, a couple builders, Concrete Builder 1 and 2. And these are the builders that will ultimately return the product. So this is sort of analogous to our factory. And these, similar to the factory, these inherit from a builder interface, well, either an abstract builder class or in this case, an interface. And the fact that these have the same superclass can be helpful when it comes to like dependency injection. The fact that these are of the same like type, they can be substituted for each other. They will ultimately return the same product type, though their implementations could be different. And that's kind of the point here. To think about it in even more simple terms, we would not even have like a second concrete builder because there are benefits of just having a single concrete builder for a certain product as well. And over here, we also have a director, and this one is definitely optional. In my experience, I don't really see it super often. But this is basically going to have an instance of the builder, and it will actually use it to instantiate some objects. So this is just kind of another layer of abstraction. Like for our client, like you could think of this as our main function or just where we are going to be using the builders in the first place. And the client will either go through the director, kind of like the wrapper around this stuff, or it will directly call build on the builders. So that's the high level. Here is kind of the concrete version of that diagram with our restaurant analogy. And in this particular case, I want to note that here we have like the builder and each of its methods, add starter, add main course, add dessert, add drink, etc. These in this particular case, they do not have any parameters, but that's not always the case with the builder pattern. This example is slightly contrived because we wanted to illustrate the use of having multiple builders that both will, in this case, return a meal. But when we get into the code, you'll see that each like add starter, it will have like a predefined starter, same with main course, etc. And kind of the flexibility that these builders in this case provide is that we don't necessarily need a starter for a vegan meal. Like it's kind of like a true false. Like either we add a starter or we don't. Either we add a main course or we don't. So that's kind of like the combinatoric explosion. Like even this does provide us a lot of flexibility because if we were to create a subclass for every single possibility, we'd end up with a lot. But this gives us some flexibility even though we can't pass the parameter directly into each of these methods. Again, that'll make a bit more sense when we get into the code. But also note here that these methods, they don't return anything. That's because we will call the methods in sequence that we want, like add starter, add main, and then at the end, we will call the .build method, and that is what's ultimately going to return an actual meal. So that's the idea. Enough talking though, let's actually take a look at some of the code. So here is some of the code. I tried to make best use of the space as I could. So here on the left, we have a healthy meal builder, and here we have a vegan meal builder. And like I said, in each of these classes, we will override those methods that we inherited from the builder class, and we'll add starters, we will add main, we'll add dessert, etc., etc. And none of these take a parameter because they will have some predefined thing. So it's grilled chicken, this one, it's veggie stir fry. These, we don't necessarily have to a parameter. And that way we kind of get the flexibility of being able to include or not include some of these. And we also get the flexibility to choose which one as well. That's the builder pattern that I'm a bit more familiar with. It's commonly used at Google for protocol buffers, which is kind of an alternative to JSON. But you can imagine with JSON or just data that you send over HTTP requests, we can have a lot of fields. We have like XYZ, etc., etc. We can have a lot of fields, and you don't necessarily want to include all of them. But for the ones you do want to include, you want to set it to some value. You want to choose a few and then map them to some value. And that's what the builder pattern can be useful for. But you can imagine in that case, in that variation, we would want to pass in parameters for every single field. That's the idea here. To show a bit of the usage, main builder, a drink, a build, suggested problem. where you can implement your own builder.
vars for first name and last name. And we want to add some validations when we and the length of the value is greater than 5, and we will also decorate the value. And what we will do is we will assign the field equals to value dot trim. We will trim the spaces and we will convert the value to uppercase. So this is the validation that we are doing. And the same thing we will do for last name as well. Now the problem with this approach is we are repeating the same kind of code. You can see the same thing we have written in two places. So what we can do is we can delegate this responsibility to other object. And it is when the delegation pattern is helpful. Now this is very small example and you might think that it is not necessary. But think about it when you have more than two variables and you have the same code in multiple places. Then delegating it to another object and keeping this code at one place is a very good idea. Because later if you want to change the condition, you need to change it in every place manually. But if you will delegate it to another object that is only one place, you will change only one place. And that is why it becomes handy and you will have less chances of making an error. So let's see how we can delegate this responsibility to other object. And to do this, we will create one more class. So I will create another class here only, and let's say we have a class and it is named name delegate. You can name it